Good morning, everyone. It is our pleasure to welcome you to the panel discussion with the topic of engineering sustainability, skills, responsibility, and innovation. Today, me, Marta Correia, I am from ESTIEM, European Students of Industrial Engineering and Management, and from University of Minho, and along with Anna, Costa from BEST, President from BEST, we will be moderating this panel discussion, and it's our absolute pleasure to have this opportunity. So also thank you to SEFI for this opportunity. We would like you to be interactive during the panel discussion. We will have also a moment for Q&A at the end. So yes, leave all your questions to the end. I'm sure all our panelists will be pleasure to answer you. And yeah, basically how our session will go. We'll first have a live poll where you'll present your vision on 2 questions. Then we'll present the panelists. Then John Mitchell, our academic challenger, will present his view as well. Later on, our company panelists will present their view on the topic. And the 3 main core topics that we will be talking about regarding the main topic are higher education's role in building a better society, educating engineers for sustainability, and social responsibility and sustainable product development. So these will be the 3 main themes that will be going after the main topic. Then there will be a moderated discussion, and then the Q&A part, and a closing by John Mitchell. And that will be the structure of the panel discussion.
Great. Thank you. Hello, everyone. I'm Anna. Already was presented. I'm the president of BEST. We will now proceed with the small Mentimeter. Yes.
Okay. All right. So, please, take out your telephones, laptops, use this QR code. This will bring you to a small Mentimeter session. What we are trying to do today, we are asking you these questions now, and then after the debate, we will ask the same questions, and we'll be curious to see whether the content of the discussion will have been able to shift your view in some way. The 2 questions are really simple, easy. No?
You can see.
Oh, I'm sorry. Yes, right. You are too kind. You should have shouted. Right. Is this better? Very good. Okay, so this is building quite nicely. All right. So government policy and regulation and education and skills development seems, you believe they have the greatest impact on sustainability in engineering. Let me move to the next one. I hope you will notice this is a session where we are bringing industry representatives, we have an academic, and we have students all together on the same stage. I believe students probably have also the possibility to lead sustainability education, but I prefer to keep it as simple as possible. All right. Okay. Well, this is neither good nor bad, but let's see, we'll see whether at the end maybe you will have slightly changed your mind. And I believe it's now the time to hand over to John. You have a microphone over there, or you can come here. It's totally up to you. Very good.
I was going to come and preach from the pulpit, I felt. Thank you, and thank you for this opportunity to speak here. My 7 minutes of provocation, I believe it was called. Engineering education has gone through a radical change, following being a very practical subject in the Victorian era, through to retrenching in technical knowledge after the Second World War. Since the early 2000s, we've seen a push for innovation, a push for skills, a push for transferable skills far more within our education. And much of that has stemmed in parallel with a lot of reports, a lot of think pieces about how the education that we've been providing to our graduates has not provided them with the skills that industry needs. And we've heard a lot about what industry wants from our graduates. And at this point, I turn to the great philosopher Jagger, who once said, "You can't always get what you want." Which leads me to a question of where is the position of industry within this conversation, and how should we work with industry, which is, I think, the fundamental question I have here. And we have to, I think, self-reflect on ourselves as a sector, both involving academia and industry. And I'm not pointing my finger at anyone, particularly this fine set of companies we have here, by virtue of being part of this, I think are at the progressive cutting edge of trying to change this. But if we look across our sector, it is a sector that is responsible for the climate change and the climate crisis that we face. It is responsible for pollution. It's responsible for arming genocidal despot regimes. It's also responsible for the fact that our workforce is only around 9% women, and very little has changed in that in a long time. And you may say much of that is in the past, but still AI is coming through, deep fake porn, these horrible things that are side issues of our, or seen as side issues of our technology, but are actually fundamental in the way we've designed and produced technology, believing that technology is neutral and that we don't have a responsibility of the way that technology is then used in society. And I'm here to provoke industry, but I think academia is equally complicit in some of the issues that we've had. And equally, I think that the title here, this idea about how we have responsibility and innovation is critical, because we often talk about sustainability, but are we thinking about the ethics of some of the sustainability we use? Are we thinking about how our technologies are diverse and inclusive? And when we look at sustainability, are we delivering to those missions as well? Is it a win if our missiles and our weapons of mass destruction are produced in a carbon neutral fashion? Should we cheer for that? My view is that we have a system that needs change, and the champions of that change has to be the students and the graduates that are coming into these positions. We must think beyond teaching within the current mode of what sustainability is, to produce graduates that are going to challenge the companies here, that are going to look to change the way we do things, change our paradigms of production so that sustainability, ethics, inclusiveness are at the centre of our innovation, are our first thoughts when we put pen to paper for a design, not an afterthought, a retrofit that is considered afterwards and seen as a metric to see if we meet a score. And that is our challenge. And it's a challenge to educators to produce those leaders, produce those change makers that are going to be the drivers of a new industry that is responsible. And I think it's also a challenge to industry of how they will nurture those leaders and allow them to become the change makers that we need to see if we're going to move beyond gradual evolution towards a more sustainable future to real step change that we need to make things that are beyond the status quo. So to conclude, I return to Jagger, because he did say you can't always get what you want. But he also said if you try, you might just get what you need.
Thank you so much, John, for the insightful words. We will now proceed with the presentation of our industry panelists. You also have the pointer.
Yeah, no. Well, I don't need a clicker because I don't have slides. I just have a note because it's 9 o'clock in the morning. I didn't have my coffee yet, so I prefer to have notes. My name is Zeljko Djuretic. I am Senior Director at Bentley, responsible for Bentley Education. Let me start with a simple statement that I believe is the truth. Sustainability cannot be optional, cannot be add-on. It is not optional. It is not add-on for current engineers. It is a core competence, and it has to be a core competence. Let me explain where I'm coming from. At the Bentley, we are infrastructure engineering software company. We serve engineers and other professionals that design, build, and operate world infrastructure. So what's that infrastructure? Infrastructure that is so essential for the quality of life, whether it is road or rail that brought you to this to Tampere, whether it is this building that we are in, or water network somewhere in rural India, and eventually bridge somewhere in Africa that connects a village with the source of clean water. Engineers that we are educating today will be responsible for that infrastructure tomorrow. And it is really up to them. It is going to be determined by their decision whether cities are going to be, whether cities can adapt to the climate change or they're not going to fall under its weight, whether energy systems are going to accelerate energy transition into renewables, or it's going to lock us in unsustainable practices, whether our infrastructure is going to be resilient, future-proof, or it is going to be brittle and short-sighted. And there is a side note to this, side note that is very dear to me, very dear to my heart, and that side note is that many young adults today worry about the world around them. They worry about their ability to do something about it. They worry about their ability to make a positive change. So I think bringing sustainability into education, explaining to young minds positive impacts of projects that those engineers are working on could be crucial really for their sense of purpose and for their well-being. So yes, engineering education I think needs to evolve. I don't think that's no longer enough to produce technically proficient engineers, but we also must equip them with the system thinking, with ethical responsibility, and with the capacity for sustainable innovation, of course. So if I look at those skills, first, system and life cycle thinking, and it's, you know, if you think about cities, it's not even a system; it's a system of systems and a life cycle thinking. So, young engineers today, they need to understand that the responsibility of their projects does not end at the construction, design and construction, but infrastructure has to be built for operations and maintenance and decommissioning eventually as well. They really need to realize, they need to understand the full impact of a human work. Second one is interdisciplinary collaboration, because sustainability challenges are incredibly complex, and engineers themselves cannot solve it. Engineers alone cannot solve it. So this collaboration between different disciplines, collaboration with stakeholders that not necessarily have any technical knowledge is so incredibly important. I think third one is digital fluency. Engineers today, engineers tomorrow need to be comfortable with using AI, with using geospatial data, with using predictive analysis, so that they can implement them in when they are optimizing use of resources already at the design phase, when they are looking at environmental impact of their projects even before construction, and so on. And fourth one would be, final would be adaptive mindset in my mind, because government's regulations are changing, technologies are changing, expectations of society are changing, and young engineers need to be able to adapt to that. But skills are not enough. I think what we need to do is also we need to foster responsibility with the engineers. They need to understand that impact of their project is not only on the budgets, but also on communities and at the generations of engineers that come after them. So they really need to understand the full impact of human actions. And they need to be able to ask themselves who is benefiting from this, who is at risk, what is the social impact of the project that I'm working on. I want to touch upon a little bit the role of industry. Traditionally, I think since industrial revolution, role of industry or collaboration between industry and academia has been ad hoc, transactional, where industry is sponsoring internships, sponsoring research projects, scholarship, and so on. Sorry. My first SEFI conference has been, I believe, 24 and 25 years ago, and we had a panel similar to this one, panel where we've been discussing a gap or bridging the gap between industry and academia. Yesterday I was following some sessions here, and I saw that we are still discussing the same topic. And in the meantime, you know, industry is doing well, academia is doing well, so maybe nothing has to change. Maybe we are fine with keeping that gap, except that today with the sustainability we are facing essential challenges. So we need to have industry working together with academia. And I don't think it is about industry leading or academia leading. It is about collaboration. Collaboration where industry works together with academia to create curriculums. And industry adds value in bringing real-life data, with bringing projects in, and with bringing data sets, so that sustainability that we are talking about, sustainability that is being taught, becomes applied sustainability. Or in other words, sustainability that can be applied, which is so crucial today. And again, stakes are much higher than they have ever been. So it is incredibly important, I think, that industry collaborates together with academia. So a little bit about Bentley roles. This is exactly what we do. We provide our technologies free of charge for academia. We obviously work on different research projects, but at the same time we are collaborating with a number of universities worldwide in order to create a curriculum that obviously uses Bentley digital twin technologies, but also that has sustainability as a core.
Zeljko, sorry to interrupt. We have a few little time, so if you can sum up in your last 3 words.
Well, so in very short, I think the transition to sustainable future is a shared responsibility. I believe that government, industry, and academia needs to work together. We want students to see sustainability, as a core competence and not as an ad hoc. And because those engineers that we are educating today will be responsible for infrastructure tomorrow. Sorry.
Thank you so much. We will now proceed with Tatiana. Yes. Go ahead.
Hello everyone, thank you very much for having us here, and we are pleased to be sponsoring this event and have an opportunity to be at this stage with such great speakers. So, I'm representing Ansys. We are part of Synopsys now. It's a global company. We are a provider and developer of software, which is obviously driven by demand of the customers, which are in turn also driven by regulations and all the legislation that we need to conform. So, what I wanted to present here, when you go through the change, and as we are in our places, we are going through the change, I think you appreciate more what happened, what you have achieved to date. And I wanted to highlight the great things which the team have achieved to date, and want you to follow, to get inspired, and to get engaged. For 15 years, and actually a person who was behind the first symposium is here, we have supported a network of educators who are materials designers, materials educators, designers, and engineering educators who come to Cambridge, and also there's another symposium chapter in North America, discuss their teaching, share ideas, talk about difficulties in teaching. And it was always a pleasure. It's a great introduction back in Granta days to community of educators, which is friendly, supportive, and engaging. Following that, our team and our academic efforts are around creating resources for educators, for teaching. You can find lots of different topics covered in this way. We have exercises, lecture units, lots of good stuff. Please check this up. And even we have great resources for STEM level education, which is engaging and a very good way to engage very young children. Fantastic opportunity to get funding for your curriculum development, to enhance it, or to have new courses. It's get some funding for that, right? It's always a good amount of time demanded to really create something new. So we have funding for that. Please do apply and use this opportunity. By the way, we have, I think, more than 30 countries now represented in this program. So we have lots of resources developed collaboratively with academics and also by them, by themselves. We also support students' teams with the free downloads for the software, and we don't leave them alone. We actually provide training. There are lots of interesting events, and they can participate in their series of webinars to learn about new technologies and how it can help them to create their projects. Another interesting initiative is the Materials Challenge. This is the way how we basically challenge our student teams around the world to create some new projects, which is also part of the criteria sustainability of their design. It's amazing, interesting results we get from young minds, and that's very inspirational. I want you to support this initiative if you can. Finally, of course, we're software developers, so we develop interesting resources. And today I will be doing a workshop on the social sustainability and how to integrate, with the help of the social impact audit tool, social sustainability discussions in engineering curriculum. I think this is a very interesting topic. There's lots still to be done. And here is another way how we can do it. So by doing all these things, we also challenge ourselves. For instance, that's an interesting project we did with the TU Delft and University Leiden, where a group of students at Industrial Technology Master course collaborated with us in designing sustainability roadmaps for Ansys. That was a very personally important project. I was collaborating with the Environmental Society and Governance Coordinator, and many people across company were taking part, giving their time, giving their resources, supporting that effort, which is beautiful to see the result and how fantastic and good quality reports we got from the students. So going into the new era, essentially we don't know how it will all develop, but we are very positive because I see our new, so to say, home. We also can see lots of efforts in STEM area. There is a Social Impact Foundation, and there are many even regional focused initiatives. For instance, in India, there's lots going on. So I wanted to say that for students, apart from the skills, I also believe they need to have attitudes, right? They need to have attitudes, they need to be able to reflect. We'll have a great speaker tomorrow or maybe Thursday about reflection for engineer. So reflection, ethical stand, communication, and hand in hand with a great ability and technical knowledge. And of course, I will say hope, it should be there, and the sense of agency. And I believe this amazing community gives that sense of agency to each of us, and our students hopefully will have the same when they go out of the universities and join the workforce. Thank you.
Thank you, Tatiana. We will proceed with Martin.
Oh, right. Good. Thanks.
Okay, so welcome and warm welcome also from my side. My name is Martin Koczmann. I work for Siemens Software for the Global Academic and Future Workforce Program. And I want to talk today about how to educate future engineers for sustainability. But before I come to the education part, I want to show you how important we as Siemens see sustainability. Our sustainability is integrated in our degree framework. Degree stands for decarbonizations, for ethics, for governance, for resource efficiency, for equity, for employability. And we set up their high targets for ourselves, but we also want to support our customers in reaching their targets. And I have some examples, and I want to start with an example from Siemens itself. Siemens has many factories all over the world, and we of course use our own tools. And this is an example from the Electronics Werk in Amberg, where we managed to reduce the greenhouse gases about 69%. We reduced the energy consumptions by 47%, and we managed to increase the output by 70%. And this while maintaining the same space and by a much more complex product palette that we are producing there. Next example would be Romi. Romi is an international manufacturer of machine tools, plastic processing machines, and cast iron. And they managed, by using our accelerator portfolio, to reduce the weight of their machine tools by over 30%, by increasing the lifespan and the quality of their products. And we have BMW. BMW created a full digital twin of their production line. And with this, they were able to also simulate the energy consumption of the production line. And with this, they could save 3 million kilowatt hours per year. But now let's have a look at how our academic program can advance sustainable education. As I said, I work for the software part of Siemens. And this is the structure of our global academic program that we have. And we believe that built on customer and industry feedback, the next generation of digital talent needs a digital mindset, a digital skill set, and they need to be able to prove this with recognized credentials. And let's start with the digital mindset. A digital mindset helps you to understand the big picture and not just the tasks that you have maybe. And we believe that micro-credentials can be here a way to build up this mindset, and can also be a way to help to teach the skills that are needed. And we have here a different way how we develop micro-credentials. The first is university cooperation. I will come to that on the next slide a bit more in detail. The second is direct-to-learner credentials. These are basically our Siemens credentials with skills that we think that someone who enters the job market should have. And we have some special course credentials. These are topics like the future of mobility, digital transformation, applied computer fluid dynamics, and such similar things. When it comes to micro-credential, very important is the quality control. And here we are very happy to work together with Arbeit. And our first our first credential pilot that we created is called Design for the Circular Economy. This was co-developed with the University of Colorado Boulder. And it contains how sustainability can be integrated into engineering practices. But it also contains topics like leadership, product management, and the greater dimension of sustainability. Besides micro-credentials, we also think that corporations are very important. So we have here our Siemens Skills for Sustainability network. Some of you might be at our reception that we had on Sunday. This is a network where we really want to exchange ideas and best practices, how to put sustainability into the engineering education. So if you're interested, please come by at our stand and we can add you to this. What we also do is we support student challenges, so to give them real-world challenges so that they can learn. We did a global challenge with students where we just asked them, show us something that you improved in a sustainable way. And we had quite a success there, and we also included there a new technology called immersive design, and you maybe saw my colleague outside on the stand. So if you're interested in that, you also can try out this. Another setup is we do hackathons. Here we ask our customers if they have something that could be make better in a sustainable way. And this is then the challenge that the students have. They have 48 hours. We invite them to big conferences, and they should come up with an idea. But we also always add this sustainability topic that this is included. Yeah, while the digital mindset is now the foundation, it's also very important that students have a digital skill set, and students, they need their hands-on on the industry tools. And therefore, we offer, of course, our whole software portfolio on one hand as licenses for campuses. So this is really the full software package that the industry is using without any restrictions that they can use. On the other hand, we have our free student downloads, so students can go there and download and learn at their own pace. And we, of course, support learning. Learning is also very important, and we have here, in reality, a commercial product that we normally sell our customers, but that we give out for free to the academic world so that people can learn and train in our solutions. And why now a digital mind and skill sets is so important, you can see here. 80% of a product sustainability impact is already determined in its design phase. And if you want to create a sustainable product, you have many things that you have to consider. It should be resource efficient, it should be decarbonized, energy efficient, it should be circular, innovative, of course, and flexible and reliable. So this is a lot of things that an engineer has to consider when creating a product. And fortunately, there are tools available that can support an engineer. A sustainable product always starts with the requirements. And we, for example, have our Team Center requirement solutions where you can define and track all requirements around sustainability through the whole life cycle. We have with our NX sustainability analysis a tool where you can see the impact of certain parts of the product on sustainability. For example, you want to change the material of a part, and then you see the impact that you have there. Or maybe a different process, how something is produced. And we already saw the BMW case. We have with plant simulation a solution where you can create a digital twin of a production line. And you not only can simulate the material flow through it and improve it, you also can simulate the energy consumption. So to summarize, students need a digital mindset and a digital skill set. Sustainability is designed and not added later. Our academic program tries to help prepare the future workforce. And join our Skills for Sustainability network if you're interested. Thank you.
Thank you so much, Martin. We will proceed now with Tanya.
No. Like this, right? Okay, good.
Hello. So, inspired by the storytelling workshop I attended yesterday, I'm going to talk today about my personal sustainability journey. An ignition point was in spring of 2019. I was mid-career, working at an education technology startup, and feeling a little lost. I went to a TEDx conference, a local one, and the first speaker cancelled. So instead, they played a video of Greta Thunberg, and her message of believe the science and act really hit home for me. And then in the coffee break, I had a transformational conversation with a climate communicator and psychologist, and I realized that what I wanted to do with the second half of my career was to maximize the impact I could have in tackling climate change. And I realized that I should return to MathWorks, where I'd previously spent 15 years and knew about the great work they were doing with scientists and engineers and engineering educators. So that's what I did. I came back to MathWorks to lead the global team of customer success engineers. So we support educators like you in integrating computational thinking and systems thinking into your curriculum. Today's panel is on engineering sustainability. And to me, sustainability means protecting and improving our Earth and its inhabitants, its people, plants, and animals, not just today, but for future generations too. So I'm going to explore three pillars. And I'm going to flip the order. We're going to look at innovation, responsibility, and skills. So technology innovation is key to building a more sustainable world. Here is a video. video is aimed at exciting students to study engineering. You see some great examples in this video of technology for things like autonomous electric vehicles, renewable wind energy systems, and drones for delivering medical supplies to remote areas. What I like about this video is you see the combination of students working on projects, the modelling and simulation and technology, and then the real-world industry application of that the students are being skilled up to work on. And when I think next about responsibility, for me, I love the UN Sustainable Development Goals. I love how they intertwine all of the important topics to work on, not just climate or sustainable consumption, but also things like biodiversity, health, education, and inclusion. I remember seeing these UN Sustainable Development Goals at the World Engineering Education Forum in India after I'd returned to MathWorks in the fall of 2019. This slide, I believe, is from Michael Milligan's, from Abet's talk. And this moment for me in the audience made me go, yes, I found my calling. This is what I want to do. I want to help engineers tackle these big global challenges. And so I took that energy back to MathWorks, and I worked with our leadership to uncover and tell our story of how we help our customers tackle climate change, including via supporting engineers in the electrification of everything. So MATLAB and Simulink are used in an amazing array of sustainability applications, including understanding sea level rise, predicting landslides, generating renewable energy, on the electrification of transport, buildings and industry, increasing the sustainability of agriculture, and improving the cooling efficiency of data centres for all that computing we love. So these applications I showed you each connect directly to one of our challenge projects. So we have a programme of about 80 projects that students can work on that you can go and have a look at. They're great for final year or master's year students where they can explore real-world engineering problems. So skills for sustainability really matter. And Engineering for One Planet, this is their graphic, offer a really great framework for thinking about sustainability skills centred on systems thinking. So at a workshop at King's College London earlier this year, we had a workshop where we needed to add climate into some existing curriculum materials. And I was partnered with a guy from Glasgow, and we reached for generative AI tools to help us quickly figure out how to integrate sustainability into one of his courses. So we ended up down some cool tangent of looking at the heat efficiency of hemp as an insulating material. It was fast and inspiring. And we built on that idea yesterday when my colleague Marco Rossi demoed how MATLAB and generative AI can help integrate sustainability into first-year engineering courses. So we took a classic first-year engineering example and we demonstrated how quickly, with the help of generative AI and MATLAB Copilot, we could add in some sustainability elements to look at what would happen if we took that pedestrian bridge in Tampere and made it of bamboo instead. It's a powerful way of accelerating curriculum development. And if you're working with faculty, you want to help along the way to integrate some sustainability, it's a really practical first step to start by adapting some of your existing materials. So that's my sustainability story so far, from a TEDx Spark to yesterday's workshop. And I look forward to exploring how MathWorks can support you as you guide your students on their own sustainability journey and learn to find and tell their own sustainability stories. Please connect with me either on LinkedIn or afterwards. Thank you very much.
Thank you, Tanya. We will proceed to our final panelist, Xavier.
Thank you. Good morning. Once more, SEFI has been well inspired in choosing the theme for this panel discussion. as it coincides quite precisely with the motto of the company I represent, which is the one you see here, a purpose that we work on by providing multiple means for everyone to model everything in the computer, especially engineers. And when I say everything, it's really everything. In 3 very large domains of human activities: manufacturing, infrastructure, cities, health, and life sciences. We call that the virtual twin of anything, big, small, close, far, today, tomorrow. And of course, we as you, as many companies, rely more and more on AI. The anticipation of the impact of AI on the energy use of computer centers in 2030, very soon, this anticipation is that this portion will be 3% of the total power consumption worldwide. Not IT, just AI, the AI portion. 2 possibilities: we can renounce to AI, we can stop using stupid AI-based transcriptions that yesterday thought SEFI was selfie, and that today made the progress of translating SEFI by safety. Did you notice? Thank you, Hanu Montana. That is you, Hanumati. So we have to offset this impact by all the good things that AI brings, or the positive impact AI can have somewhere else. Who is responsible for that? In the questions you got at the beginning, I think the good answer is everyone. I don't know if you had the possibility to check all boxes about who is responsible, but it's all levels, from the UN goals to individuals through companies like Dassault Systèmes, which I represent. And in between, initiatives such as the one that is specifically looking at the impact of AI, the Coalition for Sustainable AI, which is a global group which Dassault Systèmes is part of. Among this participation, we are working, for instance, with a company called Quanta Cloud in Taiwan that is a leader in computing centers, design and implementations. With them, we optimize a lot of the direct impact of computing center. Direct impact is very small compared to the indirect impact that comes from the general use of virtual twin in many other disciplines, not just computing centers. This impact is adding to the virtual twin assistive, contextual, predictive, and generative capabilities. These 4 things are improving the power of the impact of a virtual twin, especially when it comes to one characteristic of the virtual twin that is contextual. Being contextual means
engineering something in a universe of constraints that a single mind, a single brain cannot embrace. If I move my aluminum sourcing, I choose another type of aluminum, or the company that is providing me this aluminum has changed, it's not in Switzerland, it's in Canada now. Choosing aluminum for my system is not anymore a good solution because I have to take into account the transportation costs and many other things, but zillions of parameters that a single brain cannot embrace. So that's a typical domain where AI will also have a very positive impact. Now, what does that have to do with education? The practices of the virtual twin enhanced by AI are things that are changing the daily work of engineers and therefore should have impact on the competences of the graduates you are preparing. And that's why we work with institutions like you to follow this pace of evolution in the methodologies that engineers practice. But we also work, sometimes it's more stimulating for an educator to see a new way of doing things by the students. And the example you see now is when we tested the AI application that is powering sustainability anticipations in engineering. We are doing that, of course, with industries, but also with students. The example here is the one of the first team of students ever to have participated in a Formula One student, what's the name? Formula student competition, by having a specific role in their team for sustainability management and by using these enablement tools that we provided for taking into consideration that considerable context of the impact of their decision. The team was EPFL. We had the car on display last year. No one was looking at the car, but what we displayed was not the car. We were, in fact, trying to display what students had done in terms of adopting a new way of doing engineering. So that's why we don't have a car here. But you will have me, and you will have my colleague Tamara, who is sitting here. More than happy to answer any of your questions about the many facets of things we can do together. And normally here I should display a QR code with the website where you can find that. So, but old-fashioned wise, I like edu.ds.com. Thank you.
Thank you, Xavier. We will now go on to the moderated discussion among all of you. So, yes, to the industrial panelists, would you like to start by answering some of the prompts that were asked by John, or to focus in one of the topics that we referred at the beginning? So, does anyone want to start this first moderated discussion? We can go on with the topic of higher education's role in building a better society. Does anyone feel like developing on this topic? We can also go on to the next ones. So, Tanya, do you want to go on? Oh, basically, we are now going to further discuss among all of you what based on your statements and on what John Mitchell challenged you. We are going to discuss all of that among all of you, and then we'll have some Q&A from our audience. Yeah, basically, what is exactly your view on how to educating engineers for sustainability. Also, John Mitchell, if you feel like you can also start.
Yeah, I could perhaps reframe the question sort of tersely. I think the challenge was to say, no, I don't think education has got it right, but I also think industry is looking at, often looks at itself in that point in time. And together we need to think about the engineers of 2040, 2050. They're the engineers that we need to be thinking about what we produce. And so we need to get our mindset out of what do we need of the engineer of today to the engineer of tomorrow. And I suppose my challenge is, how together can we do that? Because at the moment, I don't think it's entirely in any of our mindset that that's what we're able to do. So.
Yeah, so I mentioned a little bit about that. I mentioned that my first SEFI conference was 25 years ago, and we had that discussion on how do you bring that gap between academia and industry. And it's not really, there was a question here, who should lead? I don't think anyone should lead. If industry is leading, then education is going to end up with the training programs, right? If academia is leading on the other side, if academia is completely leading, then students are going to end up with solid theoretical skills, but I think they're going to miss a practical aspect of that. So what is the answer? How do you foster that collaboration where industry and academia, how do you get both sides getting out of their shelves and really working together in a collaborative way? I don't have an answer.
Yeah, so let me build on that a little bit. So I also agree that, where we can have combined projects between industry and academia, then that can be the most powerful. We've had some nice examples of that where, for example, Bosch in India. Bosch are a big automotive supplier. And they were finding that it was taking them quite a long time for the new graduates to really make a difference on the electric vehicle programs they were working on. So they reached out to a local university there, NIT Calicut, to kind of go, can you help us with this challenge? We'd like your graduates to be more effective more quickly. And they said yes, and they reached out to us as a partner to help them with as well. And so we worked with them to build a curriculum, to build those concrete skills so they could really hit the ground running on electric vehicles once they graduated. So I agree, where we can collaborate together to help solve the problem industry has of hiring graduates with the right kind of skill to make an impact quickly, together with the amazing skills that universities have for training engineers for the future. I would say, though, that's quite an immediate need rather than necessarily looking, what do we need for 10, 20 years in the future, and so thinking about what are the skills that are going to be needed further out is a really good question as well. And I think a key part of that, whatever happens, will still be competencies such as communication and teamwork.
Thank you. Yeah, Martin, make sure.
I also only can agree. But I think we need to be careful not to shift the whole responsibility of saving the planet to the next generation. So it also belongs to us to think here of sustainability and not only thinking of that we have to educate now the students and they will all save us. So that's a bit burden for them maybe.
Well, I think John's question is the sliding one. 20 years ago, the same question was relevant with the horizon of today, for instance. So how good are we in predicting things? What I can observe is that many companies are thinking about the impact. How can they improve their impacts? Because the new thing in this challenge is that the question is planetary. It's not anymore a question of local competitiveness. It's a planetary issue. That's why the interplay with global actors is necessary. That's why the interplay also with the political world is important. Again, well-inspired opening speech about should engineers consider political sciences. So as a company, what we can observe is that many companies in the world, many institutions as well, are thinking about the same question and minimizing their impact through different methods. The role that we can have together with institutions like yours is to work together on taking the best of the findings we collect from these interactions with industry and make that something you can consider in your curricula. Working together on competences to build and the way through curriculum to build them. This is typically an activity that we can have. We have a team, a global team for that. If you want to learn more, again, we are here.
Just to add to that, thank you for your contributions. So we also, of course, have efforts on sustainability side in terms of a lot of interesting solutions, software for optimizing various parameters and bringing in that amazing functionality for new products. My realization is that at the forefront of all these decisions are usually functional, right? Parameters which we want to achieve. We want to make it lighter, more efficient, effective, whatever parameter you want to optimize. Then it becomes, of course, the costs, right? And then sustainability is kind of added. The real issue, how we can have this, ignite this kind of mindset in our students and in our designers and all over, to really start with sustainability questions, right? So what's the context? Who will be the users? Do we really need this product? What we are trying to achieve here? What will be the impact in the medium, long term of our decisions now, of this short term, let's say, decision, right? So that's one thing with the technology in general, and I think that's beautiful, amazing progress there. But how? What's the guidance we can give to our designers and students at this stage? Another, I think the best way how we can collaborate as well is to continue asking uncomfortable questions to industry. The pace of AI and all this technology development is enormous. There's something every day to learn, new things. I haven't, it's mind-blowing. So the questions, and let's get example of their commitments to CO2 reduction, right? CO2 emissions. So we have challenges with the data, we have disclosure requirements for companies, we have a transparency, ideally case the company really transparent about their emissions, and the targets, of course, to monitor the progress. And here we are. Why don't we have targets or boundaries for AI for social impact, right? So we have that amazing field of unknown we are all heading to, but what about really the impact on society and how we want to have this in our lives? Finally, all this synthesized data, right? How are we going to deal with this? And how we are teaching now our students to understand what's real, what's not, critically assess that, and ourselves to be able to deal with this vast data which is synthesized.
Thank you, all of you, for presenting your point of views. At the beginning, we asked our audience about who they thought that should be leading this sustainability education, if it should be either universities or the industry. Mainly the answer was the universities. So what do our industry panelists think of this? And also, maybe later on, John Mitchell can also comment on that. So yeah, who feels like starting? Okay.
It is clearly, in terms of responsibility, if it's the responsibility of engineering education. Who is responsible for education? It's the university, it's nothing else. So that's primary, yes, universities. You are accountable for providing this, or you're supposed to be accountable to provide this competences. At the end result, save the planet, you should not be alone to do that. But the competence to get there, that is in university.
I would certainly agree with that. I think there is, but it's got to be this partnership. And I think actually, in some respects, that question, I think as Alex pointed out, is perhaps framed too narrowly, that actually it is neither universities or industry. There's politicians, there's the students themselves driving in. I think these are all going to be the drivers of change to create a system that is going to make that longer-term systemic question. I mean, I think the question of politics is quite key. I mean, I think, you know, a great keynote yesterday, but of course the elephant in the room of you talk about social good against a capitalist system. How, within that context in which we currently operate, do we see the sort of progress on the one hand we're saying we want? I mean, we talk about, you know, fabulous examples of producing the things that we produce more cleanly and at lower carbon cost, but is our, you know, we go back to fundamental questions of our continued growth actually possible? Can we continue making things at the rate we do and have any hope of being sustainable within the resources we have? We laud AI, which is doing great things, but we've already taken up 5% of the US electricity and is estimated to be nearly 30% by 2028. These are growths that are unsustainable at that rate, and we need. That feels like an undercurrent that. While I completely agree, actually pushing that on to the next generation, I think we've got to train our engineers that are challenging those paradigms that we are somewhat stuck in and complicit to. They've got to be challenged, and we need radical thinking in that area, and that will come from senior leaders, but will always also come from the ground up.
So a personal opinion, and perhaps a little bit contrary to what you say. I don't think we've got time to both change our current capitalist system and mitigate the emissions that we need to do in the next 5, 10, 20, 30 years. So while I do think it's important for us to consider, is there a paradigm shift that would mean we live differently, we can't use that as an excuse not to take action right now.
But I think that's why it is important that engineering students get access to the real projects, so that they can understand the trade-offs that engineers are making every day. We can talk about clean materials. I heard some sessions yesterday, but the reality is that in coming 10 to 20 years, in the infrastructure industry that I'm part of, we are stuck with the concrete and steel. So how do you optimize that? How do you create infrastructure with what you have today? Yes, 2% will be innovators, but what about 98% of engineers? How they are going to deal with those trade-offs? How they are going to participate in that industry with the sustainability in mind? I think it's an important aspect.
Thank you all for sharing. Do you want to comment also? No. We can go on to the next question. Based on this, what do you think that the industry can do also to complement the role of the universities in this matter? So, what could be done in the next couple of years that could help the universities in their role of leading this important matter, and how can you, as industry and as professionals and developing our students after their graduation, how can you ensure that it happens over time?
I asked this question yesterday in the curriculum development SIG. What is it that we as industry can maybe provide to the education world that helps you in maybe developing courses for sustainability or whatever? Often, as software providers, we have empty tools. Maybe you need their data sets or whatever. So I think there is a good cooperation between industry and universities, but question from me was, is there anything how we can support more? Is there anything needed?
You say for the coming years, you did not say we all have things to propose to you for tomorrow morning. Go at our tables, you will hear that in detail. But the question was, in the coming years.
Yeah, exactly.
In the coming years, the nature of changes is not the one you can start tomorrow morning. It's deeper. It's broader. It's systemic. That's why the competence. Do you, if you do project-based learning, if you ask your students to solve open-ended problems, are you making sure that part of the solution goes through interviewing a political or responsible person to train them in talking their language? So these are the things at this level we can do today. Then at a broader level, at the political level, when as a company and as institutions, you universities come together to talk to policymakers, typically at European level, at EU level, then we have to invest, and we do as companies, we do invest in lobbying the pilots of the capitalist system so that they orient the general framework of rules that governs us towards the right direction. The right direction being not always looking for pure technical solutions, but also social solutions. And that passes through regulation, through law, through policy. That will not destroy the capitalist system, but we have to smartly mobilize the capitalist system in this direction.
I think the points that have been made, particularly about collaboration, are very key. And it's great to see some lovely examples of how that collaboration has really brought together projects that will impact the way that students think about business. I think your point's very clear that we can't, while we want a certain ideology, we're trying to support students to think differently. They need to be realists within the system, and I think to your point that yes, we may want to think for the future, but actually we do need to think today and make progress today. Although, I'll observe to Javier's point, if we had this conversation 20 years ago, what has changed since then, and why are we having this, a similar conversation now? It's we perhaps need both short-term and long-term thinking in this, and we are governed often by our political masters for that short-term thinking rather, and the collaborative voice, but also that bringing together of industry, academia, and importantly the student voice with that, to try and understand this quite complex ecosystem of how they relate. I don't think any one partner within that is going to make great strides. It has to be collaborative and has to be with a greater understanding of the tensions between them.
It's a very simple comment, but every one of us, right, going back home to our communities, to our families, just trying to live what you believe sustainable lifestyle is, that helps a lot.
So when I think about how can companies such as us in industry help educators and institutions in preparing students, I think we saw some nice examples from multiple of the presentations of how right now we're trying to help through things like student competitions, that get students working in teams with the latest technology to work on sustainable technology such as electric vehicles. We saw some nice examples of student challenge projects where we take what we know of our industry partners in automotive, in aerospace, in the built industry, and we try to capture some of those problems that engineers in industry are working on right now and bring that in a digestible, well-constructed challenge form that your students can work on. So and also multiple people also mentioned sort of curriculum projects and engagements and collaborations we can do to help bring the latest of what we see in industry into the context of the classroom and the projects you work on. But like Martin said, what else would you like us to do? What would be helpful? We're here as partners and keen to support you.
Actually, that's got me thinking, can I add to that? I mean, one thing that would be really useful from industry, I think, certainly in my context, is, you mentioned about it being beyond the technical skills. And now, actually, when we talk to our industry partners, they talk a lot about this, and that the graduates they want to see are not just technically strong, but understand social concepts, can work across the business. I think many of our students, when they come in, and if I'm honest, many of my academic colleagues aren't really bought into that. They believe that the thing that will get them the job, or the things that we should be producing as academics, are those technically rigorous skills, and to some degree that's someone else's problem. And I think, to be honest, many of my students don't believe me when I say things, but they often believe those that may be employing them in the future. And I think the support to get that message across, that actually we are really valuing these skills. This is what we want to see of our future graduates. We know you've gone into an engineering course at a good university, you're going to be technically strong, but that will get you the interview, it won't get you the job. These are what we want to see that are going to make a difference to our workforce, and your support in getting that message across, I think, would be very valuable.
Okay, now we can hear each other. Now I would like to challenge you a bit, and I would like you to aim high. Imagine we are now in 2050. What would you like to see happening between this collaboration, also between the industry and the universities? What would you like to see happening so that we can reach the potential of this collaboration and the synergies?
I may not be alive anymore in 2050, so I pass the question.
I think I feel the burden of being a slightly younger generation.
Well, it's a difficult question because if I look how fast technology advances at the moment, I have to say I don't have an idea where this goes to. We already heard that the energy consumption of AI will explode. On the other hand, will this gives us so much improvement that everything will be better? I just read in the morning an article where they were discussing somewhere that we, because of AI, will have a 3 weeks work week only and such things. So I guess we're in the middle of a big change, of course, and I hope the change is for the better and that sustainability there will play a role, of course. We should have the possibilities even to create green energy for AI, so it can be a way, but I don't dare to make a view on 2050, to be honest.
It's a very difficult question. Already looking at the situation now, I would like to see that there is some human aspect is left. For instance, now we're already faced sometimes that AI will generate our goals and will probably talk about our performance and whatever development personal, I don't know. So I don't want this to be totally left to AI and machines. I want people to be in charge or in charge with their good intentions.
I would say what I would like to see, if I see, is social responsible engineers. There will always be technologies that will disrupt what we are doing. There will always be challenges in the world. But if we have socially responsible engineers that think not only about technical skills, and maybe comment on what you said, technical skills might give them a job, but they're not going to give them careers. If they want to have careers, they need to have more than, they have to have other skills than technical skills. only. So yeah, social responsible engineers would be my answer.
So I'm going to not just dodge the question. I'm actually in a book club at the moment at work. We have a green workers community. And we're reading a book called What If We Get It Right? Which is looking at what's the positive vision if we do the right things in lots of different spheres. There isn't a chapter on engineering education, so let me have a go at thinking if there was. What if we get it right with engineering education and sustainability? What might that be part of? It's interesting to hear some of my panelists talk about generative AI and the impact that's going to have on teaching and learning, because I do think that's absolutely massive, and so it's a really hard place to predict what will come. What I see, though, is the ability to bring and connect people and students with the right relevant information is amazing. We talk about that skills gap, and that's partly because it's a lot of work to have that communication, to understand what do industry want and therefore what does it mean for our curriculum. So I guess if I was to dream a little, I would hope that generative AI can help make it so that it is easier for universities and students to tap into what really will be needed, what skills will I need from now, so that more of that context is available and that allows for more personalised learning.
In retrospect, I have a post-mortem dream. And I was, because when I was listening, I was also thinking about what should I answer to that type of question. And frankly, it's not a vision, it's a wish. It's the wish that we do not ignore science in our lives, in our societies, in our civilization. Because the trend today is a bad promise, the trend of forgetting science. And who else than engineers should carry science into the real life? So that's my wish. It's a desire. It's not a vision. I don't know if you will achieve it, which is to maintain science as one of the guides of our civilization. So that was post-mortem. So.
Thank you so much. One last first comment. Do you want to comment first?
I mean, I think it would be nice to have a vision of 2050 where we are no longer talking about the climate crisis and the fact that engineering and technology will save us from it. I would like to imagine that a combination of technology but also societal change has taken us away from the brink of destruction and the climate crisis is under control, and that we've moved on from the post-truth world and that knowledge is once again valued. From an education point of view, though, I would like to see a system that breaks down barriers in many ways. One, between the disciplines, that engineers are seen as technical and don't interact with the social sciences, but that actually our disciplines have merged and we've broken some of those barriers. But also that some of the issues, we're talking about university-industry interaction, partly because our current model is that someone studies for an extended period of time and then a university throws them over the fence into industry to the next stage of their career. And I would like by 2050 that we've got a rather more nuanced system where the education and the development of a professional engineer or professional of any sort is rather more collaborative between the workplace and the education, and that people will move back and forth between those. As you know, with the rapid advance of technology, the idea that you learn something at the age of 18 to 21 that will serve you for the rest of your career is, at the moment, quite fanciful, but will become more laughable as time goes on. And that actually our formal systems of education are far more permeable with industry, and that there's far more transfer between the two.
Thank you so much for all of your insightful thoughts. We've heard about the future, we've heard about also the fears within this change. And now we would like to ask our audience. I'll pass on the word to Anna, and it will be the more interactive part.
Thank you. So, any questions? I see one up there. Can we get our mic?
Try to lead the marathon.
Thank you so much. Thank you for this panel. This was really thought-provoking, and a lot of ideas are kind of coming in and clashing or interacting with each other. So my question is, how do we approach sustainability issues when the best answer is to do less, not more? So when innovation or another product isn't the answer, especially within a capitalist context.
Would anyone would like to join in on this question?
The notion of less, we can achieve less through different ways. The purely technical ones, we speak about weight optimization of the objects we manufacture. We speak about lightweight engineers, less consumption of resources. That is the technical side. Less can also be achieved through renouncing to some things. It is also an engineer's subject. How to renounce? It's a social, experiential engineering subject. It's a subject for engineers. How do I experience life without X? And what are alternate solutions that are more desirable? This is an engineering subject. It's engineering applied to making a renouncement more acceptable to society. This is something that translates into specific technical methodologies that can be learned.
Can I try to answer? So from my perspective, how do we do more with less? This is not typical for academia. This is same is true everywhere. And I think it has to do with what are your priorities? If sustainability is optional, if it is add-on, of course you're not going to do more with less. If this is a core competence, then you will approach it in a different way. So I guess the question is, what do you want your students to become once they go into the engineering world? I know, from my experience, I know that there are a number of our users that are very, very serious about sustainability, not only because of sustainability itself, but because young graduates are not going to work for companies that are not serious about it. Same is going to be true for universities. If you're not teaching sustainability, I will go somewhere where they will. So I think, again, my short answer is it's a matter of priorities, and it depends where is sustainability on your list of priorities.
I think it's one of those very difficult questions that you can't put entirely on the engineers. I mean, we've tried to push with responsible innovation. There is this question of just because you can doesn't necessarily mean you should. But equally, we know that if there's always the feeling that if one organisation doesn't, someone else will. I think the solution lies in some of the comments here in the keynote yesterday of we as engineers need to be better at explaining the trade-offs that come with that. I think far too often we're seen as, it was almost described in the keynote yesterday as the sort of technological geeks who come up with these things, and people are not seeing that AI takes 10 times the energy of Google. So we're using the AI engine as if it was Google. We're not understanding this, and we've come from a tradition where production was local, and so we feel the impact of it. In this globalized world, we do not see the impact of our actions in the same way. And this is the conversation that I think engineers are fundamental to, because we understand the mathematics that sit behind it, but we need more interaction with the political sphere to really have this nuanced conversation about what goes on.
Thank you so much. We have around 10 more minutes, and I see 2 questions. So we will go over there, and then...
So Arnold Peers from the Royal Institute of Technology in Stockholm. So my question is, why don't we take action, actually? Because we're talking about sustainability as being non-optional. We're talking about trying to explain engineering consequences of new technologies. One of the possibly most responsible things that we could do is shut down AI. So why don't we do radical stuff like that? And if you want to take a less controversial example, shut down Bitcoin mining, which has to be one of the most environmentally destructive activities on the planet at the moment and uses nearly as much electricity as AI. So I think it's an interesting discussion, but I think we need to move beyond discussion and start to exert pressure as an academic community, not just through future generations of students, but by actively using our knowledge base to affect change. So I'd just like to hear the panel's perspectives on that. Thank you.
Again, we have little time, so does anyone would like to hop in? It is, in fact, a controversial question, but it's quite thought-provoking.
Yeah, so let me chime in a little bit on the climate impact of AI and whether we should be shutting things off or not. I mean, it's interesting hearing some of the stats that people are mentioning here, because that's not actually fitting with the latest data that I'd read. I really highly recommend Dr. Hannah Ritchie, who's written some great books and blogs related to World of Data, who really tries to put the carbon footprint of AI and computing in perspective. Her latest blog was like, yes, it is 10 times more intensive than Google, but actually it's still kind of on the order of all your queries for a day might be the same as putting on the microwave for a few seconds. You know, you really do need to bring our quantitative bit to kind of look at what is the actual consumption of some of the technologies we're looking at. And the technologies are getting more efficient, even compared from a year ago to now. The amount of time and resources it takes to run an AI query are reduced. I personally think AI and generative AI is here to stay. But I also think it can encourage us to slow down a little, to the lady's point earlier, because it can take away some of the busy work and it can really put the focus on what is the actual goal. And personally, I think that if we use AI, both the classic and the more generative, to help us solve challenges of sustainability, then the net impact of that is worth it. But we do need to encourage AI literacy within our students, critical AI, and make sure we're using it mindfully, not to just create silly memes or things that are not really adding to society.
Thank you so much, Tanya. We move on to our last question over there. Do we have a mic? Yes.
Hello. Excellent. Why don't we think of sustainability as a technical skill? Like, you've been very clear, there's technability and these other things. My home department is a department of planning and sustainability, and my colleagues who are professors of sustainability certainly think sustainability is a technical skill. Why don't we? Given it's so core to all of the businesses that you're running, it's so essential to the agendas of the places we're sending all of our engineers, what's stopping us from seeing this as actually being a technical skill, core to our identities and our mission?
I think none of us said that it's not a technical skill, to be honest. And I tried to show you even some examples how our tools technically can help increasing product in a sustainable way. So there are solutions out there that can be used, that should be used. They just need to be maybe integrated in education then, at least that there is a knowledge.
Yes, I believe so. It's technical skill. And I think the really what I wanted to add, previous question, the driving forces here are, unfortunately, still the costs, and that will be the case. The costs and the regulatory framework, which it all operates. If you have a CO2 per ton, you will add some dollar sign to that, then there will be a quicker change. And there are some, of course, regulations like CBAM and so on, which will be moving companies in this direction. But yes, it's technical and it's getting more technical, more complex, and yeah, welcome.
I mean, I think Ewan's challenge is probably more to the universities who have separated it out this way, and I entirely agree. I think while things like Engineers Without Borders projects or all these things that focus on sustainability are great to have within the curriculum, they do separate it out to sustainability being a context that of things rather than, you know, thermodynamics. You need to in the context of sustainability, you need thermodynamics, and that's how you understand what is sustainable or not. You know, in construction, it's materials, it's all these things. They are fundamental, and I think that's a challenge to the universities, to the academia, of actually reframing that as central rather than, you know, you learn all this technical stuff and then you do this sustainability as a context for a project you then use it in.
Thank you so much. Unfortunately, we don't have time for more questions. However, we can always approach any of the panelists. Thank you so much for being here. Thank you for your insights. A round of applause to our panelists. No? Okay. Thank you so much. I will pass now the word to Alex again.
Okay, so let me bring up Mentimeters one more. The survey should still be open. If not, I will show you the QR code once more. I will likely make a LinkedIn post with the results comparing. And while you work on your answers, let me just leave you a couple of things for post-panel discussion. So when we say it's university and companies, we imply some sort of collaboration or partnership. And it basically takes three things to make this thing work. It takes a common goal that I believe we have somehow identified. It takes a common vision, so about how we want to get there, and it takes some intimacy between the parties involved. I believe this conference gives us good chances to build on the relationship, so please come, and as we say in SEFI sometimes, show your partners some love, come and talk to us. Yes. So this is your second question. And also, I would like you to leave us with the 3 words that you are bringing home from this session. And let me conclude by thanking the best and STEAM student for the help and the skills that they have shown managing some challenging speakers. And thank you all for being part of this. Thanks.
Thank you, well done.
Very good. Thanks a lot.
Joo, ja sitten se rehtori hänellä oli Himalajan ne oli eilen oikeasti ihan jäätäviä. Katsotaan, miten tässä seuraavina päivinä.